The concept of probability is essentially the idea of chance. If something has a 50% chance of happening, we will say p equals 0.5. P stands for probability and is between 0 and 1. An impossible event is said to be p equals 0, and a sure event is said to be p equals 1. Also, the sum of probabilities in any particular situation is equal to 1. Fundamental counting principle says that if there are A ways for one event to occur and B ways for another event to occur, then A times B is the probability of both happening. This ties into how permutations and combinations work. For example, consider the probability of getting a red queen from a deck of cards. Out of 52 cards, there are 4 queens, and half of them are red. So there's a 2 out of 52 chance of us getting a red queen when we draw randomly from a deck of cards. A permutation is an arrangement of a set of objects in a definite order of some or all of the elements in that set. A combination, on the other hand, order does not matter. So we'll do some problems and see if we can employ these elements or concepts into play. Okay. So in how many ways can you pick first, second, and third place winners among 21 people? So there's 3 slots of first, second, and third. And we can choose the first place winner among 21 people. So there's 21 ways to choose the first place winner. And then we have 20 people left to choose the second place winner. So we have 20 ways. And 19 ways to choose a third place winner because we have 19 people to pick from. So as we said in the fundamental counting principle, we just multiply these and we can get the number of ways we can pick first, second, and third, which is 21 times 20 times 19, which is equal to 7,980. Next problem. In how many ways can you choose a committee of 5 from a group of 14 people? So okay, you still have 5 slots. And to choose the first person, we have 14 ways. 13, 12, 11, and 10. Multiply those. And that is equal to 1. Okay. But the way we calculated this, order does matter. It was like as if we were picking first, second, third, fourth, and fifth. But that's not true because it's a committee of 5 and it doesn't matter in which order we pick them in. So we have to account for the overcounting that we did by dividing by the number of ways that we can arrange these 5 people. So the number of ways we can arrange 5 people would be 5 times 4 times 3 times 2 times 1, which is just 5 factorial. That is 120. So by dividing this number by 120, we can get the number of ways that we can pick 5 people when order doesn't matter out of 14 people. So that would be 2002.